this thing called sigma notation. Now, sigma is a Greek letter. It's this kind of like, I don't know, I think it looks like a monster. Like, I don't know. Every time I look at this, I'm like, oh, it's like a monster that's eating something. That's where my brain goes. But this sigma is a capital Greek letter. And it's what we use in math or statistics for sum, or adding things up. It's kind of like the capital letter S for sum. All right, so whenever you see that, that means you're going to be adding things up. Now, the first two problems here are going to be the slow way. So we have a slow, a medium, and a fast way for doing sigma notation. For 1 and 2, we're going to go the slow way. It's not that horrible. But we're going to evaluate. Now, what this says is the sum from n equals 1 to 6 of 2n plus 11. Okay. So these small numbers above and below the sigma are called the index, or the indices, if you're making it plural, of the sum. So that tells you what term you're starting at. So we're starting at first term, and we're adding everything up until the 6th term. Okay, so what it wants us to do is to write out each term in the expansion. That means what is every term that you are adding up. So here's how we do this. It's not too bad. We're starting at n equals 1. So for n equals 1, I have to figure out what term is that in this sequence. So I'm going to put 1 into this formula. That's our sequence formula here. So we'll have 2 times 1 plus 11. And what's 2 times 1 plus 11? 13. That's the first term that you're going to be adding up. And I'm going to do the same thing for n equals 2. I put 2 in for n. So I'll have 2 times 2 plus 11, which gives you 15. We haven't done math in a while, right? All right, then we do the same thing for n equals 3. n equals 4, 5, and 6. Now, if you can do this in your head, that's totally fine. You don't have to write out all the work. I'm not even going to do it all. I'll write down the next one. 2 times 3 plus 11, which is 6 plus 11, 17. And then I'm going to give you a minute. I want you to find the term for 4, 5, and 6. And you can do it in your head. You can do it on your calculator. But I at least need to see the next 3 numbers that you're going to be adding up. So I at least need to see that much. Probably see a pattern. What is the 4th term here? 19. What about the 5th term? 21. The 6th term? 23. All right. Well, those are the 6 numbers that we're adding up. That's what the sigma means. So now I want you to take your calculator. What we are actually adding up is this column of numbers. 13 plus 15 plus 17 plus 19 plus 21 plus 23. You're going to type those all into your calculator and tell me, what is the sum? What do they all add up to? What do you got, Bobby?
108.
108 is correct.
Thank you.
So what we found here, oh, look, it kind of makes an exclamation point. That's fun. Anyways, I didn't mean that, but whatever. So, right, again, the sigma means you're adding up all the terms of this sequence from 1 to 6. Now, before we move on, would you say that this sequence was arithmetic or geometric? Why would you say it's arithmetic? Yeah, because we're adding what each time? 2. Right? You can see that in the pattern. 13 plus 2 is 15 plus 2 is 17. Also, if you look at this equation here, 2n plus 11, that's what we would get for our formula, a sub n equals, once we simplify the sequence formula. So anytime you see kind of like a linear equation after your sigma, that's going to be an arithmetic sequence. Okay, so let's look at number 2. Before we start, can we identify what type of sequence this one would be, arithmetic or geometric? It's geometric, right? Because that is similar to your a sub n formula, the starting value times the common ratio. So we're going to do the same thing here. Our sigma is adding up the terms from n equals 1 to n equals 4. So to list out all the terms 1, 2, 3, and 4. So again, you're put n in 4, or 1 in for n. So I'll do the first one with you. 5 times 2 to the 1 minus 1 power. Which ends up being 5 times 2 to the 0, which is 5.
It's 5.
It is 5. Then you'll have 5 times 2 to the 2 minus 1 power. What's the next term? 2. 10. Right? Find the next term. You need to think about it. You can do your calculator again in your head, or write it down and then type it in. Doesn't matter. What's the third term? 20, and then the fourth term is 40. And again, now you have shown every term in the expansion. You wrote it out. So now you add them up. 5 plus 10 plus 20 plus 40. What do you get? Yep. That's the slow way. It's not horrible, but it's not really that fast, right? It's a little tedious. I mean, I know forever I don't want to list out every single term, but at least that shows us what we're doing. We're adding things up. So let's go from the slow method to the medium method. So the medium method we get here. Okay? So we have a sum. Now this one says the sum from 10 to 75. So we're adding the 10th term to the 75th term of 2x minus 200. So before we can move on, we have to decide what type of series is this, arithmetic or geometric. So you look at the equation here, 2x minus 200. It's arithmetic pattern. So this is an arithmetic series. Now, if I'm using arithmetic, I'm giving you, right underneath this problem, the two formulas that we could use. We have the S sub n, which is the series formula, and A sub n, which is the sequence. Both of them you can use here. But since we're adding things up, I would focus in on the S sub n formula. That's for sums and series. So when I look at that formula, I need a couple things. I need an n. I need to know how many terms I'm adding up. I need a first term, and I need a last term. So we need to identify that information. And the first thing I want to do is find the n. How many terms are you adding up? But it's not going to be that obvious. So let's go back real quick. Let's discover this. In the first one, right, I went from 1 to 6. How many numbers did you add up here? 6 of them, right? 1, 2, 3, 4, 5, 6. In number 2, I went from 1 to 4. How many numbers did I add up? 4. Okay, well, is there a way that you could use maybe those indices, those indexes, to get the number of terms we added up? Ooh, we went from 1 to 6 here. How did I get 6? Ideas? Good question. What does your instinct tell you to do? Let's go to this one. We're not doing this yet, but what does your instinct tell you to do to find the terms from 10 to 75? So you're going to count on your fingers from 10 to 75? So, okay, so subtract, right? What would you subtract? Yeah, so you would do 75 minus 10, right? So that would give you 65. Now let's double check, see if that strategy works. Let's subtract here. If I took 6 minus 1, what's 6 minus 1? 5, but we added up 6 numbers. What about over here? If I did 4 minus 1, that's 3, but I added up 4 numbers. What do you think I have to do to that 6 minus 1? Add 1. So it looks like if I take the top minus the bottom index, plus 1, I get the number of numbers I'm adding up. So that's what we're going to do down here. In this box, here's how we find n. Top index minus bottom plus 1. That will give you what your n should be. So Rachel was on the right track. I do take 75 minus 10, but then I have to add 1 to it. That gives me the number of terms. So how many numbers am I adding up here? 66. All right, that's good. I know I'm going to be adding up 66 terms. Well, now I need to use this sum formula. I know n is 66 now, but I need a sub 1 and a sub n. The only thing about this formula is that the a sub 1 here, typically when we did this in the past, we always started with the first term. But this time, we're starting at the 10th term. We're adding 10 through 75. So instead of a sub 1, this a sub 1 really just means the first term that you're adding up, which here is like your a sub 10. Okay? So we really need to find the 10th term. And what do you think I should do to find the 10th term? Don't overthink it. Plug 10 into the x here. So I'll do 2 times 10 minus 200. Remember, the formula after the sigma, that's your series formula. That helps you find the term. So we have 20 minus 200, which is negative 180. So that's the first term I'm adding up. Now I just need to find the last term I'm adding up now, which is a sub n. And what term is that? A sub 75, right? We're going up through the 75th term. So now we put 75 in for x. So 2 times 75 minus 200. And what do you get? Negative 50. Good. All right. This almost seems like it's more work than the first way, but it's better than adding up 66 terms by hand, right? Because if we did this the way we did in 1 and 2, we'd have to find the 10th, the 11th, the 12th, the 13th, all the way up to the 75th term, and that would be a lot.
I'm done with that.
Okay, I'll see you tomorrow. And tell me what the answer is.
Yeah.
Maybe you get done with that one by the time you finish class.
Okay. Okay. I get it. Well, you get it.
No!
Extra credit.
Who said that? You said that.
Yeah,
Not me. That didn't come out my mouth.
It would be a lot of work by hand.
That's why we're not doing it by hand. And also, you're going to even faster in a couple minutes. S sub 66 is what we're finding. So we need to use our series formula here for arithmetic to find the sum. So this reviews what we were doing last week or so. So S sub 66. 66 is my n. Oh, I wrote that wrong. 66 over 2. Can't talk and write at the same time. And then I put the two terms I'm going between, negative 180 plus negative 50. And then you just simply type that into your calculator, and it'll give you the sum. Let's see. So 33 times negative 230. Where is it? Oh, here's my answer. It's a negative number. Didn't figure that one out. Make sure you can type things into your calculator. I've done so much talking this afternoon, I need a drink of water.
That's why
What did you get? Yep, did you get that? Negative 7,590? All right, good. So let's do one more medium way. Then we'll switch gears and then I'll show you the shortcut. All right. Number 4. We have a sum. This sum is going from the 3rd term to the 15th term. And we have the formula 2 times negative 3 to the k minus 1. What type of series is that? Geometric. Okay? Yep, anytime you see that, it's geometric because it looks like the a sub n formula. We're going to be using the geometric series formula, which is the s sub n. This was on your quiz last Tuesday. So there's actually a little bit less work involved when we have geometric, and we've noticed that as we work with geometric here. For the formula, I need a first term, so we're going to find that in a minute. We need a common ratio, and we need an n. So let's find n first. What strategy did I just tell you to use to find n for these series, or these sigma notations? Top minus bottom plus 1. So that tells me how many I'm adding up. So 15 minus 3 plus 1 is 13. So you are adding up 13 terms. So n is 13 here. I need an r. Let's do r next. R is the common ratio. This one's pretty easy if I can analyze the formula. Which part of this equation gives me the r? Look over here if you need to. It's the number in the parentheses. So r is -3. And then I just need a starting place, a sub 1. Again, remember, we're not using the first term. We're actually starting at the third term. So I need to find a sub 3. That's where my sum is starting. So I'm going to put 3 in for k. So I have 2 times -3 to the 3 minus 1. You'll probably do that one in your head. But you don't blow yourself. What do you get? What's the third term? Where are you starting? Two times -3 squared. 2 times 9, which is 18. And I have the 3 things that I need to find the sum. So to find the sum here, I'm going to use the sum formula. S sub 13. We're finding the sum of 13 terms. So here's where you need to be really careful, like we talked about last week, with the sum formula. I start with the first term, which is 18. Now in your parentheses, you have 1 minus the common ratio. Remember, when you have a negative common ratio like we do, that common ratio needs to go in parentheses. And then your n goes right outside of that. So -3 to the 13th power all over 1 minus -3. Now I want you to very carefully type that into your calculator and make sure that you get the answer I'm going to put on the board. Because that's the hardest part of this formula, is making sure that you actually type things in correctly. Okay? So you should get this number that I just wrote on the board, but type it in, make sure that you actually do get that value. Because if you don't, then we need to double check how we're typing things into our calculator. Yes? No issues so far? We're going to switch gears here in a second. So what I've been doing is giving you the sigma notation. Now, we're going to write sigma notation.
Heck yeah.
It'll be a blast. Let's flip our paper over.
That's fun.
All right, I'm actually going to skip number 5. I want to do number 6. Then we'll do 7, and then I'll show you the shortcut. So number 6, we're going to write sigma notation to represent 2 plus 5 plus 8 plus 11 all the way up to 134. All right, well, first of all, we need to decide, is this arithmetic or geometric? Good question indeed. What type of series? Are you adding, multiplying? Adding. So this is arithmetic. So because we are arithmetic, you actually, it's not on this slide. Let me see if I can copy it. I don't know. Let's see. Nope. But all the formulas are up here. So they're on your paper. I'll write it here in a minute. But I need to write first the sequence formula for an arithmetic. Now, which one of these? You need to be able to tell the difference. Which one is the arithmetic sequence formula? Tell me the location of it in the box. Top left, the first one. So that's the formula we're going to use in number 6 here to find the a sub n formula. So I need the sequence formula in order to write sigma notation. So let's see what we have. A sub n equals, what is the first term of this series? 2 plus, what's the common difference? 3. We just like the number 2 today. And minus 1. Now, when I had an arithmetic series before, when I used sigma notation, I didn't have it written like this. I have to distribute the 3 and get rid of the parentheses. So that's the first thing you need to do. You need to rewrite this. 2 plus 3n minus 3. What does that simplify to be? Select like terms. 3n minus 1. All right, so that formula is the sequence formula for that sequence. Now, in order to make that into sigma notation, because that's what we're going to do here, first, you write your sigma. You don't have to put the little, like, I don't know, it can be as simple of a sigma as you want it to be. It's got to kind of look like that, though. So we write the sigma, and then we actually write the sequence formula right after it. Traditionally, they put it in parentheses so that you know you're taking the sum of that entire thing, 3n minus 1. Well, we're almost there, but I need to find the index, the lower index and the upper index. So here, since I'm using n, I'm going to use n equals 1. How do I find the n for 134? Any ideas? I don't know what term number that is. Right? There's a dot, 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 so I can't just count. Put it into the equation. So here's what I would do. I'll do it down here. I'm going to take 134 equal to my sequence formula. Because if I set it equal to the sequence formula, I can solve for n, and it'll tell me what term number 134 is. So I'll add 1. Get 135 equals 3n. Divide by 3. And how many terms is that? 45. I can't. I don't think I'm physically able to do that. Alright, 45. So 45 is your top index. You're adding terms 1 through 45. Yes? 1. So 2 is the term, but it's the first term. Right? It's eighths of 1. So we start at 1, we're going through 45. So now, I'm going to show you the shortcut in just a minute, but we need to find the sum. So for now, we still have to do, let's practice one more time the long way, just because it's entertaining. Not really, but it is what it is. How many terms are you adding up from 1 to 45 here? Remember, we find n by taking the top minus the bottom plus 1. So we're adding up 44 plus 1, which is 45. So we're finding the sum of 45 terms, which is 45 over 2. This is a little faster this time. What's the first term you're adding up? 2. What's the last term you're adding up? 134. This is the last long one, guys. Stick with me. Type that into your calculator. What? What does that equal? 21 times 136. I don't know. I think, I'm sorry. See, I'm coming back from vacation too. 45 over 2. I'm sorry. There. I think that's the 40 part right. That's close. Yeah. Probably because there's like a 2 on the denominator and I was like saying 45 and 2 at the same time. You talk right and do math at the same time. And not make mistakes. What is this equal? What's the sum? 3,060. All right, who wants to know the fast way to do this? I do. So here's how you do it. I'm going to pull out your calculators. Now, Alyssa, you're the only one with an Inspire, right? So here's this. You can do it too. I'll show you in a second. For the rest of you, you need your calculators out.
Are you inspired?
What?
She's inspired, yes.
No.
Anyway, so you're going to go to math. Everyone go to math here. Most of you will have this capability. There might be one of you that doesn't. So I want you to scroll through this column here and find for me where it says summation. It does. Scroll. If not everything's on this screen.
Whoa!
Where is it?
0.
0. So from now on, you don't have to actually scroll. You can just hit math 0, and it'll take you there. You'll hit math, it's summation 0, and you should get a nice little sigma. Yes?
That's such a nice.
Can you imagine how much faster this is going to be? Let's do the problem that we just finished. All right, let's type in this sigma that we just did. All right, so the only thing you have to be careful of is the calculator. You cannot use the variable n. You have to use x on your calculator. But other than that, it's the same thing. So we're going to use an x. So you type x equals, what was my lower index? 1. Arrow up. The top index was 45. Then in the parentheses, what was your equation? 3x minus 1? All right, just make sure you use an x. And then, when you hit enter, that tells you your answer. That was a lot faster, right? Do you like that method better?
Yes.
I do too. So let's go back down to the next problem. Let's set up sigma notation, and then we can use our calculator to make it faster, okay? So let's see. Oh, and Alyssa, I'll show you just a second how to do it here. Okay, so we have sigma notation. We have -3 plus 6 times plus -12 plus 24. First of all, we need to write the equation for the nth term. Well, to do that, we need to know what kind of sequence this is. It's geometric. How do you know it's geometric? Because it's alternating signs, negative to positive, negative to positive. What's your common ratio here? -2. All right, we need to know the first term when I write my geometric sequence. What's the first term? -3. So on the top of your paper is the box. But our geometric sequence formula is going to be a sub n. What would you write down? What's your equation? It's the first term, which is -3 times -2 to the n minus 1. That's pretty quick. So now the nice thing is when you get to B, when it says write sigma notation, you can write your sigma. You just write this formula right next to the sigma, -3 times -2 to the n minus 1, and we just have to figure out the index. Well, where do you start? You start at n equals 1, the first term, and how many up do you go? 21. Tells you, ace of 21, right here. Well, on a quiz and test, I don't care if you do it, you can either use the S sub n formula, or I would use your calculator. So very carefully, I want you to go back and see if you can type that into your calculator and find the right answer. Well, listen, yours is just as easy. You're going to go down to calculus, and then sum. There you go. You're welcome. All right, so let's type this. So I wouldn't even scroll. I would just go math 0, x equals 1 to 21, and then we have -3 times -2 to the x minus 1. Make sure you're using x's, and you should get that answer. Oh boy, okay. Yeah? That's not as bad, right? I would say using your calculator is the nice way to go. You do need to know, like, make sure you can use the sum formulas and stuff too, and that you can write out each term, but you're free on like a quiz or a test. If I say, give me sigma notation, and then find the sum, as long as you can get from there to then your answer, we're good. Okay? Alright, now we're going to skip then the bottom part because I taught you the calculator. I went out of order for this. So we all good for that? Alright, so you have a little tiny